My name is Upayan Chatterjee. This is my DIY lab assignment 2. This is my roll number. This is my section. So I've tried to make an anti-eavesdropping device which also serves as a touchless doorbell when you come too near to it. First I would copy this code and paste it in the Arduino IDE. There are no errors in the code. You can see there is a potentiometer which gives its output to pin A5, analog pin A5. This ultrasonic sensor which gives its output to pin 7, and this servo which is connected to PWM3. Let's see the code first. So there are three variables: sensitivity, servo input, and ultrasonic sensor output. The ultrasonic sensor output takes the value from pin 7 and I constrained it to 330 cm, from 3 cm to 330 cm, because it goes up to 335 point something, but I wanted to work with solid values, so I constrained it. This print a serial monitor. Stuff was for debugging. Sensitivity is the output of pin A5, which is the potentiometer's output. So when the sensitivity is between 0 and 230, 230 is basically the output of the potentiometer when the pointer is pointing to this point. My modes are from this point to this point. So this point to this point is mode 1, this to this is mode 2, and this to this is mode 3. So when it is between 0 and 230, then if the ultrasonic sensor detects something at less than 100 centimeters, then it would rotate servo on pin 3, which is the servo. It will rotate servo on pin 3 to this much degrees. Basically this formula converts the 3 to 100 centimeters output of the ultrasonic sensor to 0 to 180 degrees. This formula does that. And if it is greater than 100, then it would rotate to 0 degree, it would reset. This is done 3 times, from 230 to 446 sensitivity, which corresponds to second and fourth dot, and from 446 to 675. In the second mode, it detects things within 200 centimeters, and in the third mode, within 300 centimeters. This is the longest range of this setup. And in any case, if some object is within 50 centimeters range of the ultrasonic sensor, then it plays this tone, which is basically the Mario tone, which was shown to us by our professors, DIY professors. Let me start the simulation. As you can see, the potentiometer is currently in mode 1, which is 100 centimeters range. This movement does nothing because it is beyond 100. As you come nearer, you can see it crosses 100 and it deflects. You draw nearer still, it rotates more, nearer, more, and once it crosses 50 centimeters, it would trigger this buzzer, which would play the tune. As long as you are within 50 centimeters, it would continue ringing. Once you leave 50 centimeters, the buzzer stops, and now it is 121, so it is beyond the range too. Let's set it to second mode, which is here, which is up to 200. So now it detects. You go back, it recedes to. Now it is beyond 200, so it is beyond the scope currently. But once I set it to mode 3, you can see 216 is within 300 centimeters, so it rotates. Basically, the simulator time is reduced, and this time scale is this. That's why the lag. You can see it comes in mirror and it reflects more. So this is it. I would like to end my presentation here. Thank you and have a great day.